Welcome to the deep dive. We are jumping right in today because, well, I want you to imagine something. You just spent like 12,000 bucks on a brand new 2025 Kawasaki ZX6R.
Oh, man. A beautiful machine.
Right. So you take it to the track for the very first time. You're flying down the back straight. The engine is absolutely screaming, and you sit up to grab the brakes at, 120 miles an hour.
Yeah.
And the brake lever just squishes completely to the handlebar. I mean, no bite, no stopping power, just a terrifying, spongy handful of nothing.
Honestly, it is every rider's absolute worst nightmare.
It really is.
And the scary part is it happens much faster than most people realize on showroom stock sport bikes.
Well, that specific scenario actually happened to a rider in one of the community threads we're looking at today. And it perfectly illustrates why we're doing this deep dive.
Exactly.
For you listening, our mission today is to just cut through the massive, expensive aftermarket catalog for the ZX6R. We are skipping the, $1,000 full titanium exhaust systems.
Right, and the pricey ECU flashes.
Exactly. Instead, we are looking at the 5 cheapest, highest impact modifications you can make to this machine.
The real game changers.
Yep. We pulled together a pretty comprehensive research report on budget ZX6R mods, plus some hands-on installation notes from a YouTube creator named Hejimoto. He's building out a 2025 model.
Great channel.
Yeah. And we also grabbed some fiercely debated Reddit threads from the RCX6R and motorcycle communities.
The overarching theme across all those sources is a concept that a lot of newer riders just overlook.
Which is?
Building the foundation before adding power.
Right.
Throwing horsepower at a stock sport bike is essentially like dropping a 1,000-horsepower engine into a car with bald tires and bad shocks.
It's just a recipe for disaster.
Exactly. All that energy just turns into smoke and instability instead of forward motion. I mean, before you make a bike faster, you have to make it handle and you have to make it stop.
Which brings us to the very first modification on our list.
Yeah.
And I was actually shocked looking at the research report because this upgrade fundamentally dictates how the motorcycle interacts with the asphalt.
Yep.
And it often costs literally $0.
We're talking about suspension tuning.
Right.
Specifically adjusting the static sag.
I think a lot of people, they just assume a brand new bike is set up perfectly from the factory.
Well, they do. But Kawasaki, or really any manufacturer, has to build a bike for a theoretical average human.
Right, like a dummy.
Pretty much. They assume the rider weighs somewhere around 160 to 170 pounds.
Okay.
Now, the ZX6R comes equipped with these highly sophisticated Showa big piston forks in the front and a fully adjustable rear shock.
Which is great hardware.
It's amazing hardware.
Yeah.
But if you weigh 140 pounds or, if you weigh 220 pounds, the physical geometry of the motorcycle is completely out of alignment for your mass.
Okay, let's get into the mechanics of that. Because when we say geometry, we aren't just talking about the suspension feeling stiff or soft over a bump, are we?
No, not at all. We are talking about chassis pitch and steering angle.
Okay.
When you sit on a motorcycle, your body weight compresses the springs. That compression is what we call sag.
Right, the static sag.
Exactly. So if you're heavier than the factory intended, the rear end of the bike will squat way too much.
And when the rear squats.
The front end essentially lifts, which extends the forks.
And that changes the angle of the front wheel relative to the ground.
Precisely. It increases the rake angle of the steering head. The front wheel pushes outward, much like a chopper.
Oh, wow. Like a Harley or something.
Yeah, and when that happens on a sport bike, the bike becomes incredibly lazy, it refuses to tip into a corner, and it'll run wide on exits.
That makes total sense.
And conversely, if you're too light, the front end sits too high and refuses to compress under braking.
Meaning the tire can't track the pavement.
Exactly, and you lose all your front end feel.
So the fix here is literally just taking a tape measure and a wrench to adjust the spring preload collars.
Yeah. And adjusting the preload doesn't actually make the springs stiffer or softer.
Wait, it doesn't?
No, it simply raises or lowers the ride height of the bike while you're sitting on it.
Oh, okay.
You're just manipulating the chassis so it sits perfectly level under your specific body weight. That restores that aggressive, sharp steering geometry the Kawasaki engineers originally designed.
So taking an afternoon to learn how to do this in your garage unlocks the bike's true handling potential, and it's totally free.
Completely free.
Okay, let's unpack this next one. Once the chassis is leveled out and the tires are actually tracking the pavement correctly, the next bottleneck becomes the physical connection between the machine and the rider.
Oh, yes. Ergonomics.
Yeah, I want to look at tank grips. because the forums were incredibly adamant about this.
It usually are.
The way they put it, riding a polished modern sport bike without tank grips is like trying to hold a plank position on an ice rink.
That's a great analogy.
You end up putting all your weight on your wrists.
Well, the biomechanics of a sport bike practically demand them. I mean,
Yeah.
you have these low, aggressive, clip-on handlebars and a beautifully smooth, polished metal fuel tank.
Right.
So when you drop the anchor and brake hard, all of your body mass wants to slide forward into the tank.
Naturally.
And because the paint is slick, your lower body has zero purchase.
So the natural human reaction is just to lock your elbows and brace all your weight against the handlebars.
Which is the absolute worst thing you can do for steering dynamics.
Because you can't turn.
Right. A motorcycle's front wheel needs to be able to make micro corrections left and right to maintain stability. If you're using the handlebars as like a push-up bar to support your own body weight.
You completely isolate the front end.
Exactly. You can't delicately steer the machine.
So applying a pair of rubber tank grips completely rewires that dynamic. The forums highlighted that you're meant to ride a sport bike heavily with your lower body.
Right.
By sticking high-friction rubber to the sides of the tank, you can actively clamp onto the bike with your inner thighs and knees.
What's fascinating here is it transfers the braking and cornering forces directly into your core and your legs.
Right, taking it off your arms.
The moment you clamp your knees, your upper body becomes entirely unsupported by the bars. Your hands get light, your arms relax, and you regain all of your steering accuracy.
It's crazy how a simple piece of rubber can do that. But beyond the biomechanics, there's this fierce debate in the Roud's motorcycle community about which brand of grip to actually buy.
There always is.
The two heavyweights seem to be Tech-Spec and Stomp Grip. And looking at the consensus, they serve two very different types of riders.
They do, and choosing the wrong one can actually ruin your riding gear.
Really?
Yeah. Tech-Spec is overwhelmingly the favorite for street riders. Their most popular material is a softer rubber compound called the snakeskin pattern.
The research noted that Tech-Spec adhesive is a bit more forgiving, too. Like if you misalign it during installation, you can carefully peel it back and reposition it.
Right, and crucially, that softer rubber is gentle on everyday clothing.
Okay, so if you commute in denim jeans or textile riding pants, it won't destroy them.
Exactly. It provides friction without acting like sandpaper. It also prevents your jeans from scuffing the paint.
But there's a trade-off.
Yeah, their lifespan. Because the rubber is softer, ultraviolet light and general wear will degrade their grippy texture after about 3 seasons of heavy riding.
Okay, 3 seasons is still pretty good. Then you have Stomp Grip, which is essentially the hardcore track day alternative.
Very hardcore.
The community describes their volcano or icon textures as aggressive rubber spikes.
Yeah, and when you're wearing a full cowhide leather race suit, Stomp Grips are phenomenal. You dig your leather knee into those spikes and you are mechanically locked to the chassis.
Zero slippage.
Zero.
But there were massive warnings about putting Stomp Grips on a commuter bike.
Definitely.
Several Redditors mentioned that those aggressive spikes will literally chew through the inner thighs of Kevlar jeans or textile pants in a matter of months.
They will absolutely shred them.
Plus, the adhesive is strictly a one-time application. If you stick it on crooked, it stays crooked.
Right, it's a permanent commitment to track-level friction.
So let's follow the logical progression here. The suspension is dialed for your weight, the tank grips have you locked into the chassis, and your hands are light on the bars.
Everything is feeling good.
Naturally, you're going to feel a massive surge in confidence. You start braking later, diving deeper into corners and pushing the bike harder.
And that exact confidence is what exposes the terrifying mechanical weakness we opened the show with.
The 120-mile-an-hour brake fade.
Yep.
We need to dissect the physics of why that happens, because it's not the brake pads failing, is it?
No, it is a thermodynamic failure within the hydraulic system.
Okay.
When you squeeze the brake lever, you're sending hydraulic pressure down a line to the brake caliper, which squeezes the pads against the spinning metal rotor.
And the friction generated there is just immense.
It's massive. You are converting the kinetic energy of a 420-pound motorcycle, moving at triple-digit speeds entirely into heat energy.
And that heat doesn't just vanish into the air. A huge amount of it transfers straight from the brake pads through the caliper pistons and directly into the brake fluid.
And here's where the physics turn dangerous.
Uh-oh.
The factory brake lines on the ZX6R, and really most street bikes, they're made of thick rubber.
Okay.
When the brake fluid gets superheated during aggressive riding, the fluid pressure spikes. Because rubber is inherently elastic, Those factory hoses actually balloon and expand outward under the intense pressure and heat.
So instead of your hand strength clamping the brake pads onto the wheel, the energy of your hand is being wasted just stretching the rubber hose.
Exactly. That is what creates that terrifying, spongy feeling at the lever.
That is scary.
And if the fluid gets hot enough to actually boil, it introduces gas bubbles into the lines. You cannot compress a liquid, but you can compress a gas.
So once there's gas in the system, the lever pulls all the way to the bar with zero resistance.
Complete failure.
Wow. Well, the universally agreed upon cure for this in the research report is swapping those factory rubber hoses for steel-braided brake lines.
Yes, absolute game changer.
The community highly recommended kits from a company called Cormoto, which run about $150, or another brand called Spiegler, though one Redditor did warn about Spiegler's customer service.
Yeah, that happens. But the architecture of a steel-braided line solves the expansion problem entirely.
How does it work?
Inside, there's a high-temperature Teflon core that holds the fluid. And wrapped tightly around that core is a woven mesh of stainless steel.
And stainless steel doesn't stretch.
It physically cannot expand under hydraulic pressure. No matter how much heat you generate at the caliper, the steel mesh forces 100% of the hydraulic force directly into the brake pads.
So the lever feel becomes rock solid and consistent corner after corner. I do have to challenge this, though. If steel-braided lines are so cheap, I mean, $150 retail means they probably cost Kawasaki $20 at scale, and they dramatically improve safety. Why don't manufacturers just put them on the bike straight from the factory?
That's a fair question.
Are they just being cheap?
Well, it's easy to point the finger at corporate cost cutting, but veteran track riders in the Reddit thread offered a very grounded counter perspective.
Which was...
They pointed out how these bikes are actually used. For 99% of riders who use the ZX6R on the street, or even for spirited canyon carving, the factory rubber lines are completely adequate.
Wait, so the rubber lines aren't the actual cause of spongy brakes on the street?
In most street scenarios, no. The real culprit is neglected brake fluid.
Oh, okay.
DOT4 brake fluid is highly hygroscopic, meaning it actively absorbs moisture from the atmosphere. Even through the microscopic pores of the rubber brake lines, water finds its way into the system over the years.
And water boils at 212 degrees Fahrenheit, which is drastically lower than the boiling point of pure brake fluid.
Exactly. So as the fluid absorbs water, its boiling point plummets.
So the fluid boils way earlier.
Right. Several mechanics in the thread pointed out that before a street rider drops $150 on steel lines and rips their braking system apart, the first step should just be flushing out the old fluid.
Oh, wow.
Yeah, just bleed the system with a premium high boiling point racing fluid like Motul 660 or Castrol SRF.
Okay, so for a vast majority of riders, a $20 bottle of fresh fluid completely cures the spongy lever.
Yes, the steel lines are really the final necessary step for dedicated track riders dealing with extreme, sustained racing temperatures.
That makes total sense.
Yeah.
Optimize the chemistry before you replace the hardware.
Exactly.
So moving down our checklist,
Uh-huh.
we have the chassis geometry leveled, the rider physically anchored, and the brakes bulletproofed. You're carrying maximum speed through the corner.
Everything is flowing.
When you see the exit, the instinct is to twist the throttle and demand acceleration.
And this is where the engine characteristics of a 600cc Supersport often leave street riders feeling a little underwhelmed.
Which sounds crazy to say about a bike that makes 120 horsepower.
It does.
But we need to look at how that power is delivered. A 600cc inline-4 engine is engineered with massive valve overlap and short piston strokes specifically to scavenge air at extreme velocities.
They are purpose-built for the racetrack. They don't even wake up until the tachometer swings past 10,000 RPM.
Right.
Below that, in the normal street-legal RPM ranges, they produce very little torque. When you're pulling away from a stoplight or trying to pass a car on the highway in 6th gear, the engine can actually feel quite sluggish.
But the forums call out a legendary sub-$50 modification to fix this instantly.
The sprocket gear swap.
Yes. Specifically, the -1+2 mod, going down one tooth on the front engine sprocket or up 2 teeth on the rear wheel sprocket.
To visualize the mechanics of this, think about riding a multi-gear bicycle.
Okay, like a 10-speed bicycle.
Exactly. If you approach a steep hill in your highest gear, pedaling becomes incredibly difficult. Your legs bog down because you lack the mechanical advantage.
But it's like downshifting your bicycle before hitting a steep hill. You aren't adding any more muscle, you're just using your existing power way more efficiently.
Right. Your legs spin freely, the torque multiplies, and you shoot up the hill.
Okay, so a sprocket swap does the exact same thing to the motorcycle's final drive ratio.
By shrinking the front sprocket or enlarging the rear, you're artificially lowering the gearing.
And the research report notes that doing this forces the engine to spin at a slightly higher RPM at any given speed, effectively dragging the bike's power band down into the lower, usable street speeds.
Now, you are sacrificing a small amount of theoretical top speed, perhaps dropping the bike's maximum speed from 160 down to 145 miles per hour.
Which is completely irrelevant on public roads.
Totally irrelevant. And in exchange, you get a massive, aggressive increase in torque multiplication at the rear wheel. The bike accelerates much harder from a dead stop.
As one Redditor phrased it, this simple piece of stamped steel turns a high-revving track bike into a street-light torque monster.
It's the best $50 you can spend on performance.
Absolutely. So the mechanics of the motorcycle are completely dialed in at this point. It handles, stops, and accelerates brilliantly.
Time for the finishing touches.
Yeah, the final area the community and our YouTube source, Hejimoto, focused on involves streamlining the bike's physical profile and electronics. Basically shedding the restrictive, heavy street-legal components that hold back the bike's true race aesthetic.
Because every modern sport bike suffers from the same visual plague from the factory.
The massive plastic rear fender.
Yes, the one that hangs off the tail to hold the license plate and turn signals.
Right. In his video regarding the 2025 model, Hejimoto didn't pull any punches. He called the factory fender a bulky plastic diving board, which is pretty accurate.
Very accurate.
He documented his installation of a tail tidy kit from a company called Vagabond Motorsports. And what really stands out about this specific budget kit is the engineering behind it.
The aftermarket is flooded with cheap tail tidies that require you to cut into the factory wiring harness and splice in low-quality aftermarket LED lights.
Which just leads to electrical gremlins down the road.
Always.
But the Vagabond kit is essentially entirely plug-and-play. In the video, we see Hejimoto disassemble the bulky stock fender on his workbench. He unbolts the high-quality factory Kawasaki LED turn signals and the OEM license plate light.
Because the Vagabond bracket, which is made of powder-coated aluminum, is precision cut with the exact rubber grommet holes to accept the factory lights.
No complex wiring.
None! It tucks everything tightly under the tail fairing, completely cleaning up the rear profile without compromising the integrity of the bike's electrical system.
And it was actually during that tail tidy installation that Hejimoto ran into our final and easily most technical budget modification.
Ah, the exhaust servo motor.
Yeah. I was watching his teardown, and this gets incredibly frustrating for anyone trying to put a slip-on exhaust on a modern bike. Just to hear the engine properly, he pulled off the massive factory muffler.
Right.
But the factory exhaust piping contains a butterfly valve right before the muffler.
Kawasaki, like all manufacturers, uses that butterfly valve to artificially restrict exhaust flow and back pressure at lower RPMs.
Just to choke the engine enough to pass strict government noise and emissions testing.
Exactly. The valve itself is opened and closed by two steel cables, which are pulled by an electronic servo motor hidden away under the passenger seat.
Now, when you install an aftermarket exhaust, that butterfly valve is completely removed. In the video, we see him struggling with pliers to fish those steel cables out of the subframe.
But once the cables are gone, you're left with this heavy, useless electronic motor sitting under the seat.
And you have a few messy options for dealing with it. Most of them are terrible.
Yeah, if you just leave the motor in without cables, which he did temporarily, it takes up valuable space and just spins freely, eventually stripping its internal plastic gears.
But if you just unbolt the motor and unplug it from the wiring harness, the digital dashboard immediately lights up with a glaring red FI fuel injection fault code.
Because the motorcycle's computer, the ECU, utilizes a CAN bus system that constantly monitors voltage. The ECU sends a 5-volt reference signal to that servo motor, expecting to see a specific voltage return when the valve opens.
So when you unplug the motor,
The circuit goes open, the ECU receives 0 voltage back, assumes the exhaust system has critically failed, and throws the motorcycle into a panic state, illuminating the warning light.
well, Hejimoto solved this by ordering our final budget part, a servo buddy from Woodcraft Technologies, specifically the 421112 model. It retails for about $69.95.
It is a brilliant piece of microengineering.
Now here's where it gets really interesting. I have to admit, reading through the specs, the concept sounds a little sketchy.
How so?
Isn't plugging in a device to trick your bike's computer kind of risky? like putting black tape over a check engine light? Are we risking blinding the safety systems of the bike?
It's a valid concern, but that analogy doesn't quite fit the mechanism of a servo buddy. You aren't blinding the ECU, you're actively communicating with it.
Oh, okay.
The servo buddy contains a microcircuit board packed with resistors that exactly mimic the electrical resistance of the factory servo motor.
Okay, so it plugs directly into the OEM wiring harness.
Yep. So when the ECU sends that 5-volt signal out,
The servo buddy intercepts it.
right, it processes the resistance and sends the correct sweep of voltage back to the computer. So the ECU believes the exhaust valve is functioning perfectly.
It satisfies the computer logic without throwing an FI fault code, which safely allows you to completely unbolt and throw away the bulky servo motor.
Exactly.
Mojimoto pulled his out, and the amount of empty space left behind in the tail section was massive. I mean, sport bikes have notoriously zero storage space, so gaining a cavity large enough to hold a toolkit or a disc lock is a huge secondary benefit, on top of dropping the dead weight.
It really is. And with that, we've essentially gone through the motorcycle from the contact patch of the tire all the way to the microprocessors in the tail section.
Let's quickly recap the actual return on investment here. Because instead of dropping $1,500 on a full exhaust system that might net you 5 horsepower at an RPM you rarely reach on the street, look at what we've accomplished with the foundation.
We leveled the chassis geometry by adjusting the Showa forks for your exact body weight, totally for free.
We mechanically anchored your lower body to the tank and saved your wrists with $70 tech spec grips.
We utilized thermodynamics to bulletproof the hydraulic braking system against heat fade with a $150 set of Cormoto steel-braided lines.
We multiplied the rear-wheel torque and unleashed massive street acceleration with a $50 front sprocket swap.
And we stripped away the bulky emissions electronics and plastic fenders with a $70 servo buddy and a vagabond tail tidy.
We basically built a razor-sharp, track-ready weapon on a highly realistic street budget. For you listening, looking at all the physics, the ergonomics, and the mechanical engineering we've covered today, what stands out to you?
Yeah, I think it highlights that the most impactful modifications are rarely the most expensive ones. They're the ones that fundamentally improve how the machine interacts with its environment.
I completely agree. And I think there is one final, almost philosophical angle to this that wasn't explicitly spelled out in the forum threads, but it perfectly summarizes this entire deep dive.
What's that?
Well, we just spent this entire time talking about the cheapest ways to optimize the hardware of this incredible machine for your body and your riding environment.
Right?
But it raises a really provocative question to mull over next time you're looking at an aftermarket catalog.
Okay, I'm listening.
What if the absolute highest ROI, most profoundly impactful modification you can make to a 600cc Supersport isn't a piece of metal or a rubber grip or an electronic dongle bolted to the frame?
Oh, I see where you're going.
What if the ultimate secret is taking that $150 you saved and spending it on an advanced rider training clinic to upgrade the human operating it?
Wow.
Because at the end of the day, a perfect machine is really only as capable as the mind controlling it. Definitely something to think about next time you twist that throttle.